grade 12 pre-cal 6.7 applications of sinusoidal functions. This is everybody's favorite word problems. So these two examples come from your exercise book, 6.7. We're talking about question 1 and question 2, so you can take a look at those. Question number 1 talks about the London Eye. And the London Eye, if you don't know what it is, there's a picture of it right there. It's the basically beautiful wheel that's in London. You can get on these pods and go around. Okay, so what it says is London Eye has a diameter of 122 meters, reaches a maximum height of 135, right? It has to be off the ground because if not, the little pods would drag on the ground, so it has to be off the ground. And it takes approximately 30 minutes for one full rotation. So this is what it would look like, right? It's the London Eye, it's going around in a circle, 30 minutes for one rotation. But what we can do is we can translate that into a sine or a cosine. So what that would look like is, if we broke it down on here, we got our x and we got our y value here. And you can see it starts at 13 meters off the ground, right? Because it goes 135, right? Max height here, you can look. 135 minus 122, so 13 meters off the ground. It goes around in a circle, and then comes back to where you start. And we can look at a couple things. We can look at the time frame. Oh, well, let's look at A here first. So from the center of this to the top is 61. 61 meters there and there. The D is the 74 because the whole thing's been shifted up. So A and D are pretty much straightforward. What about shifting it left and right? Well, let's first talk about the period. The period is just 2 pi over the period. So 2 pi over 30. Where'd that 30 come from? Well, it's 30 minutes. So our B value is pi over 15. Okay, and if you look, a normal sinusoidal curve would start at 0. This one, if you look, it starts at 13. So if we continue this line dotted along here, it's negative 7.5. So there is a horizontal shift of positive 7.5. Okay, so actually we have everything. That's pretty simple when you look at A, B, C, and D in this case. So if it's a sine, right, 61 is our vertical stretch. Then the whole thing has been shifted up 74. Here, we change our period, so it's 2 pi over that, and then it's a shifted 7.5 to the right. Now, that's an easy one with a sine. Cosine would be a little more difficult. Cosine, you can use cosine, but there's no C value, and A becomes negative because the whole thing is flipped upside down. So if you want to do it that way, you can do negative 61 cos, pi over 15t plus 74. That one's a little bit harder to do. I find the sine in this case is the easiest to do because if you look at the graph that we did here, it looks like a sine curve to start with. Okay, flip the page and we'll talk about question number 2. Question number 2 has to do with the tide of Victoria, BC. And what it does is it reaches a maximum height of 3 meters at 2 p.m. and a minimum height at 0.2 meters at 8 p.m. So what we can do is we can figure out based another graph. So it starts at 3, it goes down to 2, goes up to 3, goes down to 2. Well, if you look at that, the whole period, there is one period of a whole day. So vertical center, 3 minus 0.02 divided by 2, so 1.6, right? Do not add anything this because it goes from low to high tide. So the period is 12 hours. Because if you look at this, start to finish is 12 hours. 2 p.m. to 2 a.m. or 8 p.m. to 8 a.m. It doesn't matter how you look at it. So the period is 12 hours. Well, how do we find B? 2 pi over 12, so pi over 6. The graph is at a maximum when t is 0. Now, if you look, hey, this looks like a cosine curve. So let's just base it on cosine. We don't have to change it to sine. Okay, so what we get here is we get our shift. A is 1.4. Where do we get that from? Well, that's a vertical stretch, right? If we look at the center here, the whole thing would be stretched here. So 1.4. Horizontal compression here in this case. So pi over 6. And the whole thing's then been shifted up 1.6. So we do our vertical stretch, shifted up 1.6, and then our period based on that. So that's really easy to do if it's cosine. Okay, now you can work on those questions.